Well, in this lesson, we thought that if you're given a polynomial function in factored form, you can factor it by finding the x-intercepts, the y-intercept, and then seeing its behavior above and below the x-axis to get a sketch of the graph. What about if we're asked to work backwards? Okay. So here you're given a graph, you're asked to find the function. Well, it's going to look something. It's going to look something like this. I don't know how many sets of parentheses there are, but it's going to look something like that. And maybe some of these might be squared, maybe they might be cubed even. Okay? So how do I figure out, and it's going to be x and x and x and x. How do I figure out what numbers go in each set of parentheses? What was the relationship? Weren't these numbers, whatever value of x, made the expression 0, and that was one of the x-intercepts? So let's go backwards. What's one of the x-intercepts? 1. So what would it be in factored form? X minus 1 in order to get positive 1. Okay. Give me another one. Negative 1. What would it look like in factored form? X plus 1. And there's one more. 3, but what's so special about this one? It bounces back, which means it has a multiplicity of 2. So it becomes minus 3, but because it bounces back, it's a squared, and that's it. I don't need this last one. So it looks like, and I'm going to put this in here, it looks like it's going to be this, according to the x-intercepts. But how do I know? Maybe there's a number in front here that's stretching. How do I know that? I got to check the y-intercept. What's the y-intercept for this one? 0 minus 1 times 0 plus 1 times 0 minus 3 squared. What does that give me? Positive 9 or negative 9? Positive 9 or negative 9? Okay, you're saying positive. This is negative 1. This is positive 1. This is positive 9. So it's negative 9. Okay? But look at the graph. What's the y-intercept? What's that? No, it's going up. It's going down by 2's. So it'll be right there, halfway between negative 8. Like this is negative 8. This is negative 10. So what would this be? Negative 9. Do they match up? So I'm done. I found it. But they're not always going to match up, so we're going to have to make a correction. Okay, so this one was pretty straightforward. X minus 1, x plus 1, x minus 3 squared. And that's it. Let's look at the next one. And again, according to the x-intercepts, it looks like what? Give me a set of parentheses with the correct number in it. X plus 4, because this is minus 4, so that means it's x plus 4 is the factor. X plus 1 matches up with that. X minus 3 matches up with that. None of them bounce back, so I don't have to put any squares on any of them. So it looks like this. What's the y-intercept from this one? Negative 12. What's the y-intercept from the graph? This time it's going up by 4, so it's positive 12. What would I have to multiply this by to change this from negative 12? Because this is the correct one, right? Because according to the graph. What would I have to multiply this by to get this? Negative 1. So that means, so I'm going to have to times by negative 1 to get that, which means I'm going to put a negative 1 in front. So that's what I mean by sometimes you might have to make a correction so that the y-intercepts from what you think it is to what it actually is correct. So this would be y equals negative x minus 1, x plus 1, x minus 3 all squared. Sorry, x minus 3. X minus, well, what am I doing? Oh, geez, I just wrote the one above there. Never mind. X plus 4, x plus 1, x minus 3. Okay. So it's a little bit easier going backwards. I want you to try this one. Be careful with one of your x-intercepts because it goes through, but it flattens out. That should tell you something about the exponent. So it looks like y equals x plus 2. But because it goes through and flattens out, that's multiplicity. So that means it's a cube. This goes straight through, so it's just x minus 1. So the y-intercept of this one is going to be negative 8. 2 cubed is 8, times negative 1 is negative 8. But from the graph, the y-intercept is negative 1. Well, I've got negative 8 right now. I need to multiply something in front to make it negative 1. What does I multiply by? 1 over 8. Because we're making it smaller, right? Always. Well, you know what? So if you went like that, technically, that's correct. It would be, because that would be the same as times 1 over 8, times 1 divided. So, I mean, yeah, I mean, if I saw that, but you should always get into the habit of what you multiply by. Because remember, we did that when we were finding, when we were doing stretches in the first unit. It was always what we multiplied by. But no, that's good comment. So we have to times by 1/8. So therefore, our final equation is going to be 1/8 times x plus 2 cubed times x minus 1. Okay? Tell me you're not coming in late and then using your phone. Tell me you're not. Tell me you're seeing things. This one. Looks like. But x plus 1 squared, because it bounces there. X minus 1, because it goes through. X minus 2 squared. Because this is a bounce back, it's a multiplicity of 2. And because this is a bounce back, it is also a multiplicity of 2. So it looks like that. The one that it looks like, what would this y-intercept be? So this is 1, -1, +4. So it'd be -4. But from the graph, it's 2. Which means, what do I have to multiply -4 by to get 2? -1/2. So it's going to be -1/2 times x plus 1 squared times x minus 1 times x minus 2 squared. Okay. Okay, that takes care of